phase volume ratio on stability of emulsions. Effect of phase volume ratio on stability of emulsions. So here the phase volume ratio is one of the parameters to determine the stability. So it is one of the parameters to determine the stability of emulsions. So it is phase volume ratio is one of the parameters to determine the stability of emulsions. And what is meant by phase volume ratio? Phase volume ratio is nothing but it is the ratio of the volume of internal phase to the total volume of emulsion. So here phase volume ratio is nothing but it is one of the stability parameter which indicates the stability of emulsions. So for example, if you take in last lab we done suspensions, right? In case of suspension, what is the parameter, stability parameter? Sedimentation volume. So if you done the dosage form, that is suspension. So if you want to determine the stability of suspension, we have to estimate sedimentation volume. Similarly, in case of emulsions, so if you prepare the emulsion and if you want to estimate the stability, whether it is stable or not, so then we have to estimate phase volume ratio. So here the phase volume ratio is nothing but, so it is the volume of internal phase to total volume of the emulsion. For example, if you take oil in water emulsion, which is the internal phase? Oil is the internal phase. Internal phase is oil. For example, you prepared oil, you take 10 ml and you made the emulsion up to 100 ml by using emulsifying agent. మీరు castor oil, liquid paraffin oil, different oils తీసుకొని if you prepared the you take 10 ml of oil and you made the emulsion by using emulsifying agent, either it may be predacant or acacia, and you made the volume to 100 ml. So here the internal phase volume is how much? 10 ml. Total volume of emulsion is? Then what is phase volume ratio? Phase volume ratio of this emulsion is 10 by 100. So that means 0.1. So if you prepare the emulsion, oil in water emulsion by taking 10 ml of oil and you prepare the total volume of emulsion is 100 ml, then that emulsion has the phase volume ratio of 0.1. So if you take 20 ml and you made the emulsion 100 ml, then phase volume ratio will be 20 by 100 and 0.2. So similarly, if you take 30 ml, 0.3, if you take 40 ml, 0.4, like that we get. So what is the relation between this phase volume ratio and stability of emulsion means? Whenever the phase volume ratio is high, from the textbook or from the literature we know that generally whenever the phase volume ratio is high, the stability of emulsion is greater. So what is the relation? So generally we know that whenever the phase volume ratio is high, the stability of emulsion is also high. So that need to be remembered. So if any emulsion which is having a high phase volume ratio, it indicates it is having a high stability. So to prove that, to understand the relation between phase volume ratio and stability of emulsion, so practically we need to prepare 4 different emulsions, A, B, C and D. So we had to prepare 4 different emulsions with 4 different phase volume ratios. For example, the first one, A emulsion is prepared with the phase volume ratio of 0.4, and the B emulsion is prepared with a phase volume ratio of 0.3, and emulsion 3 is prepared with 0.2 phase volume ratio, and D emulsion is prepared with 0.1 phase volume ratio. So to know the relation, to know the effect of phasor, we know that whenever the phase volume ratio is high, stability is high. So to prove that, what we had to do, we had to prepare the emulsions with different phase volume ratios. 4 different emulsions need 4 different phase volume ratios, so we had to prepare. So first emulsion 0.4 phase volume ratio ante oil ante teeskovali. We had to take 40 ml of oil and we made the emulsion 100 ml. Similarly, to prepare the phase volume ratio of 0.3, we had to take 30 ml of oil and we made up to 100 ml of emulsion. And 0.2 phase volume ratio emulsion, we had to take 20 ml of oil and we made up to 100 ml of emulsion. Similarly, to prepare 0.1 volume ratio of emulsion, we had to take 10 ml of oil and we had to prepare 100 ml of emulsion by using emulsifying agents. So after that, after preparing all these emulsions, 4 different emulsions with 4 different phase volume ratios, so to observe the stability, we had to keep aside, transfer into the measuring cylinder or transfer into beaker, and we had to keep on observing which emulsion shows the phase separation. So first we had to do the 4 different emulsions and we had to transfer into beaker and we have to keep on observing. So it may take few days or it may take few months. So we had to keep on observing the emulsions, which emulsion is separated first. So from the literature or from the knowledge, what we know that, so generally phase volume ratio, if the phase volume ratio is less, it shows the separation first. So among these, which one is showing first phase separation? Emulsion. D will shows the first phase separation. And next C emulsion. Next B emulsion. Finally, A emulsion, it take long time for showing the phase separation. So it is a time-taking procedure. In laboratory scale, what we are done means by centrifugation method. So after preparation of all these emulsions, we had to subjecting for centrifugation. To fasten the phase separation, we are subjecting for centrifugation method. So for that, what we had to do means all these emulsions are transferred to the centrifugation tubes. 10 ml emulsion was transferred to centrifugation tubes. Each emulsion is transferred to 4 different test tubes. We had to transfer 10 ml of emulsions and subjecting for centrifugation for 10 minutes. So 10 minutes centrifugation yesterday. So there is a phase separation. Here the centrifugation method will fasten the phase separation. So thereby after centrifugation for 10 minutes, we can observe the phase separation in test tubes. So this may be the emulsion and this is continuous phase. Here we can clearly observe the extent of phase separation. This is extent of phase separation. Extent of phase separation. For all the suspensions, after centrifugation for 10 minutes, we had to measure with a scale how much centiliters of phase will be separated. So if you know that, if we can from the knowledge we know that, so among these 4 different emulsions, the D emulsion will shows the high phase separation, whereas A will shows the less phase separation because of high phase volume ratio. So we have to prove that of the emulsion is high. We have to do that. For that, we need to prepare the emulsions with 4 different phase volume ratios and subjecting for centrifugation for 10 minutes. Then there is a possibility of phase separation. Phase will be separated. So we had to measure how extent, how much centimeters of phase was separated. So among that, we know that, so emulsion D will shows the higher amount of phase separation, whereas the emulsion A will shows the lesser amount of phase separation. So to know the actual results, we have to do the experiment and we have to prove that the phase volume ratio, whenever it is high, it is having a high stability. Prepare the emulsion by primary emulsion formula. First add acacia and to this add liquid paraffin drop by drop from the side with continuous trituration. Mix until uniformly the acacia and oil was mixed together. Now add water slowly from the side in a drop by drop with continuous trituration, and triturate in one direction only to avoid separation of emulsion. The milky white emulsion was formed. Four different emulsions with 4 different phase volume ratios. 4 different emulsions with 4 phase volume ratios. Each emulsion is transferred 10 ml into test tubes, centrifugation tubes. Four different emulsions were transferred to 4 different test tubes, centrifugation tubes. On change, switch on. So always we need to keep test tubes in equal opposite sides, in equal proportions. So always we need to place in balance mode. Subjecting for centrifugation, note down the time, 10 minutes. So subjecting for centrifugation for 10 minutes. After the centrifugation, the extent of phase separation. The extent of phase separation was measured with the help of scale discernum. So here there is a separation of phase. phase was separated. So if you see, the extent of phase separation was more in case of EA formulation, whereas the extent of separation was less in case of first formulation. Yeah, the extent of phase separation was more in last formulation, that is D formulation, whereas the extent of phase separation was less in first formulation. It indicates the formulation with the 0.4 phase volume ratio, it is a more stable. The formulation with phase volume ratio, the last one, that is 0.1, it is a less stable. Yeah, so they all are